Walk into any classroom and you'll see two opposite behaviors playing out in real time. In the front row, a student is leaning in, asking questions, and testing the logic of the lesson. Two desks back, another student is staring at the clock, doing the bare minimum required to avoid trouble. They are in the same physical space, listening to the same teacher, and studying the exact same content. Every environmental variable is identical. The difference is motivation. But what we traditionally call motivation is often a misunderstanding of how the brain actually decides to exert effort. Usually, when we want to drive a behavior, we reach for external pressure. We use high-stakes grading systems, verbal pressure, or the promise of a tangible reward for compliance. In the short term, this strategy is effective. If you tell a student they must finish a task to avoid a failing grade, they will likely finish the task. But this approach has a shelf life. Genuine drive cannot be imported. It has to be generated from within, or it eventually runs out. This is extrinsic motivation, any action performed solely to capture a reward or evade a punishment. Then there is intrinsic motivation, an action performed purely for internal satisfaction. This illustrates the gap between the two. Extrinsic forces start an action, but intrinsic forces sustain that action once pressure is removed. The uncomfortable truth is that many standard teaching frameworks are effectively designed to kill this internal drive. We create environments of excessive pressure, remove personal choice, rely on rigid formatting, and keep the material isolated from the real world. When students stop trying, it isn't a mystery. It is the direct result of an environment that has stripped away their reason to care. We often call this apathy laziness. In reality, it is a logical human response to a setting that offers no rational reason to exert effort. To reverse this, we have to look at the three specific pillars required to design a self-sustaining learning environment. The first pillar is autonomy. It requires giving the student a degree of control over their own work. This can be as simple as letting them choose their own research topic, pick their presentation format, or decide which specific approach to take when solving a problem. When a student has a say in the process, they take more personal responsibility for the result. This represents the second pillar, competence. To stay engaged, students must feel the task is achievable. Faced with an impossible monolith, the brain triggers a surrender response, seeing no path to success. We build competence by deconstructing macro tasks into manageable micro steps and providing rapid feedback. Once a student can say, "I know how to do this," they are much more likely to keep going. The final pillar is relevance. This is the proof that the information actually matters. Every student is silently asking one question: why should I care about this? If that question isn't answered, the brain classifies the information as noise, and motivation disappears. We create relevance by tethering concepts to real-world scenarios, showing how knowledge will be used in the future, and connecting it to what students understand. When data has personal meaning, it stops being abstract noise and becomes necessary knowledge. Contrast a standard directive, learn this because it's on the test, with a relevance-based approach. Learn this because it's the tool you need to solve this specific real-world problem. Repositioning a concept as a useful tool rather than a hurdle to jump changes the student's entire operational logic. Motivation isn't something you force into a person. It is an architecture you have to design. It requires three specific materials: a sense of autonomy, a clear path to competence, and undeniable real-world utility. When those elements are in place, the dynamic changes. You no longer have to push students forward, they start to pull themselves.